Hello, this is Serene from Exam Hub Lab. Today I'll be solving Physics Paper 2 AS Level Structured Questions 9702 Paper 2, wherein 3 October, November 2017. Question number 1, Part A, define power. So power is energy transferred or work done divided by time taken. Part 2, show that the SI base units of power are kilograms meter square per second cube. So energy is force multiplied by distance, and time is in seconds, so this becomes kilograms meter square per second cube. Part B, all bodies radiate energy. The power P radiated by a body is given by the following equation, where T is the thermodynamic temperature of the body, A is the surface area of the body, and K is a constant. Determine the SI base units of K. So K is equals to power radiated by the body divided by area into thermodynamic temperature to the power 4. Power SI base units for the power is kilograms meter square per second cube divided by meter square into Kelvin to the power 4. Hence the SI base units for K constant is kilogram per second cube per Kelvin to the power 4. Part 2, on figure 1.1, sketch the variation with T square of P. The quantity A remains constant. So P and T do not share a linear relationship. It's P is equals to T to the power 4. T to the power 2 is on the x-axis, as it can be seen right here, and P is on the y-axis, which forms an equation of y is equals to x to the power square, where x is T square. So this is going to be a parabola shaped graph with positive gradient. So a parabola from the A origin and a positive gradient graph. Question number 2, a liquid of density fills a container to a depth of h, as shown in figure 2.1. The base of the container has area A. Derived from the definitions of pressure and density, the equation pressure is equals to density into G into h, where P is the pressure exerted by the liquid on the base of the container and G is the acceleration of free fall. So density is equals to mass divided by volume, and pressure is equals to force divided by area, where volume is equals to cross-sectional area into height, and F is equals to mass of the liquid and G. So when we equate both these equations, this becomes density into cross-sectional area into height is equals to pressure into cross-sectional area divided by G. Area and area, they get cancelled, hence pressure is equals to density into G into H. Part B, a small solid sphere falls with constant velocity through the liquid state. The names of the three forces acting on the sphere. So there is going to be the weight of the sphere, there's going to be drag force, and the upthrust due to difference in pressure at the top and bottom of sphere. So weight, second is drag force, and the third is upthrust. A word equation that relates the magnitudes of these forces. So since the sphere is traveling with constant velocity, all forces that are acting on it must be balanced. So the weight that acts downwards must be equal to sum of drag and upthrust that act upwards. So drag plus upthrust. Part 2, state and explain the changes in energy that occur as the sphere falls. So the height of the ball is decreasing, hence GPE is decreasing too. So first of all, gravitational potential energy. And with that also comes drag force that causes resistance to the ball's motion. So increase in thermal energy due to work done against drag force. Part C, the liquid in the container is liquid L. Liquid M is now added to the container. The two liquids do not mix. The total depth of the liquids is 0.17 meters. Figure 2.2 shows how the pressure inside the liquids varies with height x above the base of the container. Part 1 state the value of atmospheric pressure. So at the bottom of the container, the pressure is 9.25 into 10 to the power of 4 pascals, and that on the top is 9.1 into 10 to the power of 4 pascals, which is the atmospheric pressure. So it's 9.1 into 10 to the power of 4 pascals of pressure. Part 2, determine the density of liquid M. For us to know the density of liquid M, we should first look at the figure 2.2. So the pressure due to liquid M starts from 9.15 to 9.1, and the change in depth due to this change in pressure is 0.17 to 0.1. So density is equal to change in pressure divided by G into change in the depth of liquid. Change in pressure is from 9.15 to 9.1, which also has into 10 to the power 4, divided by 9.81 into the change in depth is from 0.17 to 0.1, that's of 0.07 meters, and hence the density of liquid M is 728 kilograms per meter cube. Question number 3, part A, state the principle of conservation of momentum. Law of conservation of momentum says that for an isolated system, total momentum is constant. Part B, ball A moves with speed v along a horizontal frictionless surface towards a stationary ball B as shown in figure 3.1. Ball A has mass 4 kilograms and ball B has mass 12 kilograms. The balls collide and then move apart as shown in figure 3.2. Ball A has velocity 6 meters per second at an angle of theta to the direction of its initial path. Ball B has velocity 3.5 meters per second at an angle of 30 degrees to the direction of the initial path of ball A. Part 1, by considering the components of momentum at right angles to the direction of the initial path of ball A, calculate the value for theta. So momentum in y components before collision is going to be equal to that after collision. So momentum in y components before collision is 0, since a ball A is only traveling along the x-axis and ball B is stationary, so momentum in y components before collision is 0. This is equal to momentum in y components after collision. So this ball A travels with angle theta. So the y component that this ball travels has a speed of 6 sine theta, and ball B travels vertically with a speed of 3.5 sine 30. And since ball B has a vertical component that acts downwards, it's going to have a negative sign to its velocity, and this will have a plus sign to its velocity. So momentum after collision along the y-axis is going to be the mass of ball A multiplied by its velocity in the vertical component plus the mass of ball B multiplied by its velocity along the y-axis, which is negative 3.5 sine 30. So this becomes 24 sine theta is equals to 21, hence theta is equals to 61.04 degrees. Part 2, use your answer in part 1 to show that the initial speed v of ball A is 12 meters per second. Again, total momentum along x-axis should be constant. So momentum before collision along the x-axis is going to be 4v, and that after the collision is going to be the sum of 4 into the x component of the velocity of ball A, which is 6 cos theta, plus momentum after collision of ball B along x-axis, which is 3.5 cos 30. And both of them, they are towards the right, so they're going to carry positive signs. So mass of ball A before collision, it has a momentum of 4v, and after collision it has a momentum of 4 into 6 cos Theta, we already had calculated the value for theta, which is 61.04, plus the momentum of ball B after collision along the x-axis, and that is equals to 12 into 3.5 cos 30. So this gives us the value of V as 12 meters per second. Part 3, by calculation of kinetic energy, state and explain whether the collision is elastic or inelastic. So kinetic energy before collision is going to be equal to that of the kinetic energy of ball A, which is half into the mass of ball A multiplied by the velocity V, and that after collision is going to be equal to the sum of the kinetic energies of ball A and B. So before collision, kinetic energy is equals to half into the mass of ball A multiplied by the velocity V, that is 12 square, and this is equals to 288 joules of kinetic energy. And that after collision, kinetic energy is equals to half into mass of ball A multiplied by its velocity, and the velocity of ball A after collision is 6 and that of B is 3.5. So 6 square plus half into 12 into 3.5 square. So total kinetic energy after collision is 145.5 joules. Since kinetic energies are not equal, so the collision is inelastic. Question number 4, part A. By reference to the direction of propagation of energy, explain what is meant by a longitudinal wave. A longitudinal wave has oscillation that is parallel to the direction of propagation. Part B, a car horn emits a sound wave of frequency 800 Hz. A microphone and a cathode ray oscilloscope are used to analyze the sound wave. The waveform displayed on the CRO screen is shown in figure 4.1. Determine the time-based setting in seconds per centimeter of the CRO. So frequency of 800 Hz means that the time period for this wave is 1 by 800, and that is equals to 1.25 into 10 to the power of negative 3 seconds. This means that from this trough to its adjacent trough, this is equals to 1.25 into 10 to the power of negative 3 seconds. This is the time period of one complete oscillation, and that is comprised of in total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this comprises of 13 small boxes, and 1 centimeter is of 5 small boxes, as it can be seen here. 1, 2, 3, 4, 5. 13 boxes are going to be 13 by 5, and that is equals to 2.6 centimeters. So 2.6 centimeters is for one complete wave. So 2.6 centimeters for 1.25 into 10 to the power of negative 3 seconds. For 1 centimeter, it's going to be 1.25 into 10 to the power of negative 3 divided by 2.6. And hence the time-based setting for the CRO is going to be of 4.8 into 10 to the power of negative 4 seconds per centimeters. Part C, the intensity I of the sound at a distance r from the car horn in B is given by the expression where k is a constant. Figure 4.2 shows the car in B on a road. An observer stands at point O. Initially, the car is parked at point X, which is 120 meters away from point O. The car then moves directly towards the observer and stops at point Y, a distance of 30 meters away from O. The car horn continuously emits sound when the car is moving between points X and Y. Part 1, the sound wave at point O has amplitude AX when the car is at X and has amplitude AY when the car is at Y. Calculate the ratio amplitude at point Y and amplitude at point X. So intensity is directly proportional to amplitude square. So we can also say that amplitude is directly proportional to root of intensities. We first need to find the intensity of the car horn at point X and that on point Y. So intensity at point X, this is going to be equal to, we are going to use the formula that is given to us in the question. Intensity at any point is equal to K by distance square. So intensity at point X is going to be equal to K divided by the distance between point O and the car which is at point X. So distance between O and point X is 120 meters. So Ix is equals to K by 120 the whole square, and intensity at point Y is equal to K divided by the distance between point Y and point O where the observer is standing. So that is 30 square. So 30 square. Now amplitude of the sound wave at point Y by amplitude at point X. This is going to be proportional to the intensity at point Y and its root. So K by 30 the whole square divided by the intensity at point X and its root. So K divided by 120 the whole square. So this will become root K by 30 divided by root K by 120, and hence we have the ratio for these amplitudes as 4. Part 2, when the car is parked at X, the frequency of the sound from the horn that is detected by the observer is 800 Hz. As the car moves from X to Y, the maximum change in the detected frequency is 16 Hz. The speed of the sound in the air is 330 meters per second. Determine to two significant figures the minimum wavelength of the sound detected by the observer. So the frequency of the source of the sound, that is the car, is equals to 800 Hz at point X, and the maximum, and it says that the maximum change in the detected frequency is 16 Hz. So change in frequency is of 16 Hz, and the car is approaching this observer. So the new observed frequency at point Y is going to be equal to 800 plus 16, is that 816 Hz, and the speed of sound is 330 meters per second. So the minimum wavelength of the sound detected by the observer, so this is going to be equal to the speed of the sound in air divided by the frequency of the sound. So 330 is the speed and 816 is the highest frequency that can be heard, which produces minimum wavelength. So this is 0.40 meters. I did not take 800 Hz of frequency over here because relatively it will have a larger wavelength. Okay, now determine the two significant figures the maximum speed of the car. At maximum speed of the car, V minus Vs, which is the denominator of our main formula, which is observed frequency, is equals to frequency of source into V divided by V minus Vs. At maximum speed of the car, V minus Vs is going to be the minimum, and the observed frequency is going to be the maximum that's observed, which is 816 Hz. So 816 is equals to frequency of the source of sound at point X, that is 800, into the speed of sound in air divided by speed of sound in air minus speed of the source of the sound. And when you rearrange your formula, you get the speed of the source of the sound as 6.47 meters per second. Question number 5, part A, define electric field strength. This is force per unit positive charge. Part B, two parallel metal plates in a vacuum are separated by 0.045 meters. A potential difference V is applied between the plates as shown in figure 5.1. A proton is initially at rest on the surface of the positive plate. The proton in the uniform electric field takes a time of 1.5 into 10 to the power of -7 seconds to reach the negative plate. Show that the acceleration of the proton is 4 into 10 to the power of 12 meters per second square. So the initial speed of the proton is 0. The time it takes to travel from the positive plate to the negative plate is 1.5 into 10 to the power of -7, and the distance it covers in between is 0.045 meters. And we are supposed to find the value for the acceleration. So we can use the formula as is equals to ut plus 1 by 2 AD square, where acceleration is equal to displacement that it travels multiplied by 2 divided by the time it takes to travel between these two charged plates and the square of it. So the acceleration is 4 into 10 to the power of 12 meters per second square. Part 2, calculate the electric force on the proton. So force is equal to resultant force is equals to mass into acceleration. The resultant force that acts on the proton is only due to electric field. So mass of the proton is 1.67 into 10 to the power of negative 27, and the acceleration with which it moves towards the negatively charged plate is 4 into 10 to the power of 12. And hence the resultant force that acts on the proton is 6.68 into 10 to the power of negative 15 newtons. Part 3, use your answer in part 2 to determine the electric field strength. Electric field strength is equals to force divided by charge. Force exerted on the proton from the previous part is 6.68 into 10 to the power of negative 15, and the charge of a proton is 1.6 into 10 to the power of negative 19. Hence, the field strength that acts on that proton is 4.18 into 10 to the power of 4 newtons per coulomb. The potential difference V between the plates. So electric field strength again is equals to change in voltage divided by the distance between the charged plates. The electric field strength from the previous part is 4.18 into 10 to the power of 4, and the distance between the charged plates is 0.045. So V is going to be equal to the product of both those two values. And hence we have the V between the plates as 1.9 into 10 to the power of 3 volts. Part C, an alpha particle is now accelerated between the two plates in B by the electric field. Calculate the ratio acceleration of alpha particle and acceleration of proton. So acceleration is equals to resultant force divided by mass. The resultant force that acts on the alpha particle is going to be equal to the charge of the alpha particle, the V between the charged plates, and the distance between the charged plates. Now, alpha particle carries 2 protons, so the total charge on alpha particle is 2 into 1.6 into 10 to the power of negative 19. The voltage between the charged plates is 1.9 into 10 to the power of 3 divided by the distance between the charged plates, which is 0.045 meters. Hence we have the force as 1.35 into 10 to the power of negative 14 newtons. Now, acceleration is equals to 1.35 into 10 to the power of negative 14 divided by the mass of the alpha particle. Alpha particle carries 2 protons and 2 neutrons, so in total 4 multiplied by 1.67 into 10 to the power of negative 27. Hence, the acceleration of the alpha particle is 2.021 into 10 to the power of 12. Now, the ratio of the acceleration of alpha particles and proton, this is the acceleration of the alpha particle divided by the acceleration of the proton from the previous part, which is 4 into 10 to the power of 12. So 4 into 10 to the power of 12, and you get a ratio of acceleration as half, which is 0.5. Question number 6, a filament lamp is rated as 30 watts, 120 volts. A potential difference of 120 volts is applied across the lamp. For the filament wire of the lamp, calculate the value of the current. So power is equals to current into voltage, where power is 30 watts, current is unknown, and voltage is 120. Hence the current that passes through it is 0.25 amperes. Part 2, the number of electrons passing a point in 3 hours. So for that, we need to first find the amount of charge that passes through the wire of the lamp in 3 hours. So charge is equals to current into time, which needs to be in seconds. So 3 hours into 3600 to convert that to seconds. And the amount of charge that passes through the wire is 2700 coulombs in 3 hours. Now, charge of 1.6 into 10 to the power of negative 19 coulomb is of 1 electron. So 2700 coulombs means that 2700 divided by 1.6 into 10 to the power negative 19 is the number of electrons that pass through the filament wire of the lamp in 3 hours, and that is 1.7 into 10 to the power of 22. show that the resistance of the filament wire is 480 ohms. So resistance is equal to voltage divided by current. The voltage across it is 120 volts and current that passes through it is 0.25, and this is equal to 480 ohms. Part C, the filament wire has an uncoiled length of 580 millimeters. Let's convert it to meters right away. So this is 0.58 meters and is made of metal. The metal has resistivity 6.1 into 10 to the power of -7 ohm meter at the operating temperature of the lamp. Calculate the diameter of the wire. So resistance is equal to resistivity into length by cross-sectional area, where cross-sectional area is equal to, in terms of diameter, is pi d squared by r. So resistance becomes 4 resistivity into length by pi d squared. Resistance of the filament wire of the lamp is 480, is equal to 4 into 6.1 into 10 to the power of -7 into 0.58 divided by pi d squared. Hence, the diameter of the filament wire lamp is 3.06 into 10 to the power of -5 meters. Part D, the potential difference across the lamp is now reduced. State and explain the effect, if any, on the resistance of the filament wire. So this decrease in the potential difference across the lamp causes temperature of the filament wire to reduce, and as a result, its resistance will decrease too. So we can write that temperature of filament wire decreases and resistance decreases too, since they are directly proportional to each other. Question number 7, part A. Nucleus X decays by emitting a beta plus particle. So here is X. Beta plus particle has a nucleon number of 0 and a +1 charge here to form a nucleus Na. So Na has 23 and 11. State the number of nucleons and the number of neutrons in nucleus X. So this will have 23 over here and 12 over here. And the number of nucleons is the mass number, that is 23. And the number of neutrons is going to be the difference between the nucleon number and the proton number, that is 23 minus 12, and that's 11. Part B, state one similarity and one difference between a beta plus particle and a beta minus particle. So they share the same mass, but they have opposite charges. This carries a charge of +1 and this carries a charge of -1. So opposite charge. So that was it. Thank you for watching.